Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go.
Welcome to lesson 24 of GMAT Math Basics. This is the final lesson in our Math Basics series, and by the end of this episode, you will have, if you've listened to every episode, been exposed at least once to all the basic math that you would need to know to get a great GMAT quant score. Let's wrap up this course by discussing some of the concepts that are super important, but don't necessarily warrant an entire lesson unto themselves. As always, let's begin with a quick quiz, and there's a quiz like this at the beginning of every lesson in this series, and I'll give you some advice about how I recommend engaging with that at the end of this episode. Let's start our quiz. Question 1. What happens when I multiply and divide by the number 1? Question 2. What happens when I multiply and divide by the number 0? Question 3. What are even and odd numbers, and how do they work together? Question 4. Is 0 even or odd? Question 5. What are prime numbers? Question 6. What are real numbers? Question 7. What are ratios, and how do you write them? Question 8. How do you multiply positive and negative numbers? Question 9. What is the domain and the range of an equation? Let's go. Question 1. What happens when I multiply and divide by the number 1? It might seem like it's not even worth discussing multiplying and dividing by 1, but it can come up during the exam, and it can sometimes be the difference between being right and being wrong in a question, as crazy as that sounds. It may have been a long time since you thought about division and multiplication by 1. In fact, you may have never thought about it. So let's just quickly discuss it. Anything multiplied by 1 does not change in value. That's because 1 times anything is just counting that thing one time. So it has the value that it already has. Contrast that with multiplying a value by 2. That will change the value because 2 of something is almost always different than 1 of something. The same thing is true of dividing by 1. Dividing something among one person is not really dividing at all. So when a number is divided by 1, its value doesn't change. Think about dividing 10 oranges evenly between 2 people. Each person would get 5 oranges. But if you think about dividing 10 oranges among one person, that person would just get 10 oranges. And that can help you understand the concept of dividing by 1 and also multiplying by 1. Multiplying is just counting the same number over and over again. If I count that number one time, it just has its original value that it already had. That's multiplying and dividing by 1. Question 2. How do we deal with 0? Another number that creates unusual results. Let's start with adding and subtracting, which is kind of obvious. Most people will understand that adding nothing to a number does not change its value. And the same can be said of subtracting nothing from a number. Value doesn't change. But what about multiplying by 0? That can be a little bit less intuitive. I'd recommend thinking about it this way. If you're multiplying by 1, and that means counting something one time, then think of multiplying by 0 as counting something 0 times. No matter what number we're counting, if we count it 0 times, the result is 0. There are other ways to think about this, but I think that's the simplest. You can also think about it as adding something 0 times. So 3 times 1 is adding 3 one time. It's counting 3 once. That would have a value of 3. But adding 3 0 times or counting 3 0 times has a value of 0. We started with nothing and added nothing to it. That's why any number multiplied by 0 is 0. That's worth memorizing. Again, it might seem a little strange to even discuss this or to think about it at all, but it does matter on the GMAT, and so it's worth understanding. Many GMAT questions test this concept of 0 precisely because so few people have taken the time to understand it. Fortunately, now that is not you. You're now someone who hopefully understands this concept of multiplying by 0 well, or at least well enough. What about division by 0? It might seem reasonable to think that anything divided by 0 is also 0, but that is actually not true. Technically, division by 0 is quote unquote undefined. And that's a math term for we haven't figured out how to deal with this yet. So let's dive into that a little bit more. Division by 0 is such a problematic concept in math that the GMAT just doesn't even allow it. So think about it as like out of bounds in a sport or a game. It's like against the rules to divide things by 0. It just cannot be done on the GMAT. So think about it that way. Dividing by 0 is simply not allowed on the GMAT. That's worth memorizing. How might that play out? If an answer seems to divide by 0, you can consider that answer choice out of boundaries and just eliminate it. It's like against the rules of the game. So if you wind up dividing by 0 in your own work, you have probably made an error, and you should check your work and consider even guessing and maybe moving on from that question. Maybe you just fundamentally misunderstood something about that problem. Happens sometimes. And honestly, it's not the end of the world when it happens. Try not to panic. Just move on. You can always come back to it later. Now, conceptually, the reason that division by 0 is not allowed can be kind of difficult to understand. It's very, very theoretical. So I would recommend, like I said before, just memorizing that division by 0 is not allowed on the GMAT and keeping it that simple. If you really care about the reasoning behind it, and I did construct a whole lesson on this and decided to just delete it from this episode because I think it just makes things more complicated than necessary. And you're probably here because you want a great GMAT score as fast and easy as possible, not because you want to understand division by 0 on a deep level. However, if I am wrong about that, then I tested this out, and most generative AI chatbots will be more than happy to walk you through the concept of division by 0 on a deep level. So if that's you, then find your generative AI chatbot of choice and ask away. For now, let's stay focused on what's going to be essential for your personal preparation. I think naturally that leads us to the concept of dividing 0 by other numbers. So like we just talked about how you cannot divide a number by 0, but what about dividing 0 by 3 or dividing 0 by 10? Fortunately, this is much more intuitive. 0 divided by any number is 0. Think about it this way. What's 0 oranges distributed among 10 people evenly? It's 0. Everybody gets no oranges. Perhaps obviously, the only exception is 0 divided by 0, which is not allowed. If we divide 0 by a non-zero number, though, we will get 0 as a result 100% of the time. We'll actually return to 0 in a little bit, but before we do that, let's talk about the difference between even and odd numbers. What is the difference between even and odd numbers, or just what are these? We held off on this concept because it's actually not essential for understanding a lot of the other basic math, like operations and equations that are very foundational to great GMAT scores. But even and odd numbers are tested heavily enough that it's worth understanding. You may recall our conversation about divisibility from early on in this program. If you want to understand divisibility better, we discuss it in depth in lesson 4 of this series. So feel free to pause and go back to that and then return if you want to understand divisibility a little bit better. Hopefully you recall, if you have gone through that lesson, though, that if a number is divisible by another number, then that division would generate an integer result. That's important because the way we define an even number is that it's divisible by 2. That means that if you divide it by 2, you get an integer. That's how we define an even number. If I divide it by 2 and get an integer, it's even. Quick example, 10 divided by 2 is 5, and 5 is an integer. So 10 is considered an even number. I can divide 10 by 2 and get an integer result. Again, even just means it's a special type of number that happens to be divisible by 2. It's a somewhat arbitrary designation, but it is heavily tested, and so it's worth being familiar with. If we try to divide 5 by 2, though, we do not get an integer result because 5 times divided by 2 is 2.5, or 2 and 1/2 if you think about it as a mixed number, or 2.5 if you think about it as a decimal. We've talked about that a lot in this series. But basically, it's not an integer. That means that 5 is not even. 5 over 2 is not an integer, ergo 5, not an even number. Integers that are not even are called odd. 2, 4, 6, 8, etc. are all even. 1, 3, 5, 7, etc. are all odd. Evens and odds have some interesting properties, so the GMAT likes to test those concepts. For example, adding two odd integers always produces an even integer. I think that's a little bit unexpected, but it's true, so you'll see that concept tested a decent amount. Similarly, adding an even and an odd integer always produces an odd result. Some folks out there recommend memorizing these kinds of rules, and I don't think that's a bad idea at all, but I do want you to know that it's not critical for your success. As long as you remember that there are rules for addition, subtraction, and multiplication of even and odd numbers, then you can derive those rules during the test. So if you're feeling like you're getting a little maxed out with memorization, just memorize that rules exist for addition, subtraction, and multiplication of even and odd numbers. If you want to memorize the specific rules themselves, then a quick web search will net you all of those rules. You can make some flashcards and you should be good to go. Quick example of this. If I know there's a rule about adding odd integers, I don't have to remember what that rule is because I can sum any two odd integers and know that that result will hold for any two other odd integers. So again, that's just memorizing that there are rules. For example, 3 plus 5 is equal to 8. If I do that on the test, then I know that any two odd integers will produce an even result when I add them. So that's why I'm saying it's not crucial to memorize those rules. But if you like having them memorized, there's absolutely nothing wrong with that, and you can go ahead and do so. One important note here is that there are rules for addition, subtraction, and multiplication, like you heard me say twice, but there is no real rule for division. Almost anything can happen with division of even and odd numbers, so you'll want to memorize that when dividing even and odd numbers, you'll want to test the result on a case-by-case basis. Okay, so it might be worth memorizing there's no rule for division of even and odd numbers, and you'll want to test division of even and odd numbers on a case-by-case basis, meaning use the specific numbers in that problem to do the division and get the result. Don't be thinking about like some generalized rule. A quick example of this, 10, which is even, divided by 2, which is even, is 5, which is odd. But 10, which is even, divided by 6, which is even, is not even an integer result at all. Something like that would never happen with addition, subtraction, or multiplication of even and odd numbers. Hence my previous point. Memorize that there are rules for adding, subtracting, and multiplying even and odd numbers, and also memorize that there is no rule when dividing even and odd numbers. That should take care of business when it comes to the basics of evens and odds. Now we can return to 0. Is 0 even or odd? What about positive or negative? As we discussed, 0 is kind of a unique value, and it's worth considering more about 0 because, again, it's heavily tested. So let's start with, is 0 even or odd? Remember that the definition of an even number is that it generates an integer when it's divided by 2. 0 divided by 2 is just 0, like we talked about earlier. Because 0 is considered an integer, and the way we would define integer is no decimals and no fractions, then 0 is considered even on the GMAT. There's plenty of debate about this in the mathematical community, but for the GMAT, you will treat 0 as an even integer. Importantly, 0 is neither positive nor negative. Positive and negative numbers are actually defined by their relationship to 0. So 0 exists outside of both categories. Why does that matter? Well, on the exam, if a question tells you x is a positive integer, you know that x cannot be 0. And the exam will expect you to make that inference. For better or for worse, that could be the difference between getting the question correct versus incorrect. So I would recommend memorizing that on the GMAT, 0 is even, it is an integer, and it is neither positive nor negative. I would memorize those things. Next up, the concept of prime numbers. Again, a special type of integer. Prime numbers are kind of like a special case of division. we define prime numbers as numbers that have exactly two distinct, meaning different, factors. Those factors will be the number 1 and the number itself. Now note that by that definition, 1 is not prime, because 1 has only one distinct factor, 1. Okay, so while you might have treated 1 as a prime number in other contexts, on the GMAT, 1 is not prime. On the GMAT, prime numbers have exactly two, meaning no more and no less, different factors. For example, 5 is a prime number because the only integers that divide 5 evenly are 1 and 5. 1 and 5 are different numbers, ergo, 5 is prime. Some other notable examples are numbers like 7, 11, 13, 17, and 19. One that's really worth putting your attention on is 2. 2 is actually the smallest prime number because there are no negative primes, and I'll save you the history lesson, but basically prime numbers were invented before the concept of negative numbers, and people just didn't want to mess up their existing theorems derived based on primes, as far as I understand the history. Maybe someone can correct me. And so that's why there are no negative primes. Kind of a funny thing if you think about it, but again, we just want to focus on the GMAT here. So what's important for the GMAT is 2 is the smallest prime number, and it is also the only even prime number. All other prime numbers are odd. The GMAT really likes to hammer that point. So if the GMAT says x is an even prime number, that's a roundabout way of saying x is equal to 2. You might see something like that. The GMAT tests the concept of prime numbers in general quite heavily. You will see it come up a lot, so I recommend starting to memorize all the prime numbers between 1 and 100. This can take some time. That's why I said I'd recommend just starting now. But if you're looking for a great quant score, you'll probably be really happy that you memorized all of them between 1 and 100. Past 100, it's definitely going to come up so infrequently, maybe never. So probably not going to get a lot of value out of that. If you wanted to know, there is technically an infinite number of prime numbers, but the GMAT's not really going to go there. So we don't have to go there with our prep. For now, be sure to memorize the definition of prime numbers, though. Prime numbers have exactly two different factors, 1 and the number itself. That means 1 is not prime. 1 has only one distinct factor. Again, that also means that 2 is the smallest and the only even prime. The only integers that divide 2 are 2 and 1. Those are different integers, though, so 2 is prime. The most important thing to know about primes right now, again, is just the definition. Once you understand that, you'll be able to speak enough of the GMAT's language to make progress with a course or a coach or a good self-study program, whether that's free or paid. And that's really the goal of this course. Primes will show up in all kinds of ways, and you'll discover that more and more as you progress through more advanced material. This program is specifically focused on the basics, so for now, we're just going to move on. And you can start making flashcards and or memorizing in your preferred way all the primes between 1 and 100. That brings us to the concept of real numbers. Real numbers are worth discussing just so it doesn't confuse you when it's mentioned on the test. It might be kind of strange to think about the concept of a number that's not real, but leave it to some mathematicians to create such a concept. This concept is called imaginary numbers, and they are useful for some types of math, but I do want to be clear that they're not allowed on the GMAT. The only reason I'm discussing imaginary numbers right now is that it's the basis for a concept that is important on the GMAT. So let's get into that. On the GMAT, imaginary numbers are not allowed. So think about them like division by zero. It's just out of bounds. It's against the rules. Why do we care about that? Imaginary numbers usually result from trying to take the square root of a negative value. If you don't know what square roots are or you want to understand them better, just head back in the feed to lesson 17 of this Math Basics series, and I'll talk you through everything you need to know about roots. Assuming you have some familiarity with roots, square roots of negative numbers don't actually exist. Here's why. When you square a number, you multiply it by itself. If the number you're squaring is positive, you will multiply a positive number times itself and get a positive result. Positive times positive is always positive. We'll talk more about that in a second. If the number you're squaring is negative, you'll multiply a negative number times itself. A negative times a negative is always positive, and so either way, when you square numbers, the result is positive. The only exception to that is squaring 0. And just because we're on the subject, if you take the square root of 0, that is 0. Square rooting 0 is allowed because 0 times 0 is 0. But back to positives and negatives, because of the positive-negative situation when squaring all non-zero numbers, it's impossible to take the square root of a negative number. That result does not exist because there is no number that can be squared to produce a negative result. It's not possible. Now, again, some mathematicians got together and decided they were going to make up numbers that could fill in that gap, and those are called imaginary numbers. The only reason this matters on the GMAT is that, again, imaginary numbers are not allowed. So when the exam tells you something is a real number, or it says assume all numbers are real, what they're really saying is square roots of negative numbers are not allowed. That's them just reinforcing that rule in a very conceptual way. That can kind of throw people off if you haven't considered it before. So that's why I'm talking about real numbers. Just to be more specific, the way this usually plays out during the exam is you'll be asked if a number could be a solution to an equation. So like, which of the following could be a solution to the equation above? That could be like a multiple choice math question. But if any solutions would require you to take the square root of a negative number, all you need to remember is that that solution is against the rules. And so that will not be the answer to the question. You can safely just eliminate anything that involves square rooting a negative. That's probably the best way to memorize it. If I see a square root of a negative on the GMAT, eliminate that answer. Or double check my math and consider skipping the problem like I talked to you about before. Again, if a solution to an equation requires taking the square root of a negative number, that can't be a real solution to the equation, and you would not select an answer choice that includes that solution. Okay? Apologies if that feels a little complicated, but the takeaway is simple. Just memorize that the square root of negative numbers are not allowed on the GMAT. Remember that and you'll be good. Quick note, at the start of the quant section, you'll see an instructions page, and that'll tell you that all numbers on the exam are quote unquote real. If you've never considered imaginary numbers before, that might not mean that much to you, or it might be like weird or confusing, like, whoa, what does that mean? It can cause some anxiety. But hopefully now that makes sense and you don't have to worry about it. Again, memorize that square roots of negatives are not allowed on the GMAT. If an answer involves square rooting a negative number, it's wrong and should be eliminated. That brings us to the concept of ratios. Ratios are kind of similar to fractions, but they're also different in really important ways because fractions represent only part-to-whole relationships. Let me illustrate. If there are 2 boys and 7 girls in a science class, what fraction of all the students is boys? Well, there are 2 boys and 9 total students, so the fraction of all the students that's boys is 2/9. That should be a familiar concept. Sometimes that's what you want to express, and you want to visually and or numerically depict that part-to-whole relationship. In that case, you would just use a fraction. But what if you wanted to represent a part-to-part relationship, such as total number of boys to total number of girls? That's what ratios allow you to do. Fractions represent part-to-whole relationships. Ratios represent part-to-part relationships. Sometimes it's more convenient or more desirable to express part-to-part relationships. Now, ratios can be expressed a couple different ways. One of the most common ways is part and then a colon. If you've never seen a colon before or heard that term, it's a period with another period right above it. That's a colon. So you would see a part of a situation with a colon and then another number, which is representing another part. That would let you know that's a ratio. 2:7 would be a 2:7 relationship. In our case, 2 boys and 7 girls, it would be written as 2:7. That would let you know there's 2 boys for every 7 girls in a class. You'll want to be able to recognize what that means on the GMAT. That's the most important thing for the basics. Another way ratios can be written is actually using the word to, T-O, instead of the colon. Might be a little bit weird if you haven't seen that before, but you'll want to get used to it because the GMAT can use both interchangeably. That's pretty much it for the basics. There's actually plenty more to discuss regarding ratios, including many strategies that can help you get GMAT ratio problems right. But for now, those are the main basics that you'll want to be familiar with. And again, we want to stay focused on the basics here so that when you start a course or self-study program of your choice, you'll be able to proceed quickly, which is our goal for you. The fastest and easiest results you can get. Quick summary of ratios. They represent part-to-part relationships rather than part-to-whole relationships. Part-to-whole relationships are represented by fractions. Ratios can be written with a colon or the word to, T-O, between the numbers, as in the ratio of boys to girls in a class is 2:7. That's it. Let's talk about multiplying positives and negatives. I briefly mentioned this a moment ago, and this can actually get kind of complicated. Again, I had a whole theoretical lesson prepared for you today, and then I just realized it was like massive overkill and like probably more confusing than helpful. So we're just going to keep this as simple as possible. You'll want to memorize that positive times positive equals positive. Any positive number times any other positive number will always be positive. You'll also want to memorize that any positive number times any negative number will be negative. Any positive number times any negative number will be negative. These rules apply to integers and non-integers. They apply to decimals, fractions, every kind of number. You'll finally want to memorize that a negative number times another negative number will always be positive. Again, positives and negatives exist outside the concept of zero or only in the relation to zero, so we don't need to consider multiplying by zero here. Anything times zero is zero, and we already covered that. Again, the why behind these rules can get very theoretical, and I think most people taking the GMAT just don't care. Definitely let me know if I'm wrong about that. Understanding it probably won't help your score, so memorizing is probably the way to go here. If you want to know more about some of the technical and theoretical aspects of why positive times negative numbers are always negative, then again, touching base with your preferred generative AI chatbot of choice should help a lot there. That brings us to the final concept that we're going to cover in this Math Basics series, which is domain versus range in equations. This is a set of terms that really does not come up very often at all. Having said that, when it does come up, if you get them confused or you don't know how to handle them, it's going to make getting that question super, super hard. So because that could cause a lot of stress and hurt your score, let's just memorize a couple things. Number one, the domain of an equation is the set of all things that you are allowed to put into the equation. So the domain represents allowable inputs. If you had an equation that involved 5 over x, then 0 would not be in the domain of that equation because you're not allowed to divide by 0 on the GMAT. Hopefully that makes sense. But something like 7 would be in the domain because we can totally divide 5 by 7 on the GMAT. That's the domain. Doesn't come up very often, but when it comes up, it's super important. So I recommend memorizing that the domain of an equation are the things you are allowed to plug into that equation. The range are the things that can result from an equation. So certain types of equations will have a limited number of results that they can produce. Again, the theoretical concepts behind that, not worth discussing. It's just worth memorizing that the domain represents the things you can plug into an equation that are allowed, not against the rules. And the range is the set of things that can result from an equation, or set of values that can result from an equation, if you want to be technical. That's it. That's really all I recommend understanding about domain and range. Just memorize it. Probably not going to see it, but if you do, you'll be happy that you memorized them. That's it. That is it. Pat yourself on the back. You have now been exposed at least once to all the basic math for the GMAT exam. So what's next? I recommend continuing the quizzes at the start of each episode until you cannot forget these basics. This is the foundation of the next level of your career. It's a big deal, so please invest accordingly. I've tried to make this as easy and as painless and as convenient as it could possibly be. If you are already involved with a GMAT provider or you're on a self-study plan that you're happy with, simply continue that. That is the next step in your process. If you're not sure where to go from here or which kind of provider is going to be the best for your personal situation, because there is no universal best provider in the GMAT space, please listen to our How to Start Your GMAT Studies in 2024 episode. That's way back in the feed from January of 2024. It's called How to Start Your GMAT Studies in 2024. It's really important to listen to that episode, not the first episode in the entire series of this podcast from 2019. We'll be updating that soon to let people know about the new version of the exam. But there's a new version of the exam in 2024, and you'll want to be prepared for that specific version of the test because it's quite different from the old version. Now, we're also going to link that episode in the description of this content. So if you don't like typing and you'd rather just click on that, if you're on mobile or something, then by all means, please do so. If you are not sure how to proceed with your GMAT studies right now. Again, if you've already got a program that you're happy with, simply continue that program and enjoy being on the next level with your basic quant knowledge. If you have questions at any time, please find us at the GMAT Strategy on current social channels, or you can email us at contact, which is spelled CONTACT, at thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how to reach your dream GMAT score in half the normal time. I know that might sound crazy, but it delivers. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.